Welcome to our deep dive into modern technology. Today, we're pulling back the curtain to reveal how laptops, the tools we rely on every day, are meticulously designed, assembled, and tested. Let's journey from the creative spark to the moment you power on your device. Every laptop starts with an idea. In the initial stages, product planners, industrial designers, and engineers come together to map out the vision. Using advanced CAD software like SolidWorks and AutoCAD, they craft a digital blueprint that defines every curve, component placement, and thermal vent. The design team employs computer simulations to ensure optimal thermal performance, structural integrity, and user ergonomics. This planning phase isn't just about looks. It's about technical precision and the seamless integration of components. After detailed sketches and 3D models, prototypes are built. These early models are rigorously tested for performance, durability, and usability. Feedback from these tests drives iterative refinements that will shape the final design. Once the design is locked down, the focus shifts to the heart of the laptop, which is its components. Let's take a closer look at how these critical parts are produced. At the center of every laptop lies its processor and graphics unit. These chips are manufactured at semiconductor foundries such as TSMC or Intel. They use photolithography, a process where ultraviolet light shines through a patterned mask onto ultra-pure silicon wafers to etch billions of microscopic circuits. Modern fabrication advances have shrunk these processes from 14 nanometers nodes down to 7 nanometers and even 5 nanometers, increasing both speed and energy efficiency. The most advanced processes now even employ extreme ultraviolet (EUV) lithography, using light as short as 13.5 nanometers to achieve unparalleled detail. The motherboard, which interconnects all components, is created via multi-layered PCB manufacturing. Here, thin layers of copper are laminated onto insulating substrates. Computer-controlled drilling and milling machines precisely create the circuit patterns that will connect your laptop's components, setting the stage for the next automated assembly phase. Volatile memory, RAM, and non-volatile storage, SSDs, are produced in cleanroom environments. Flash memory cells, often based on NAND technology, are carefully engineered and then assembled into the modules that quickly deliver data to your processor. Your window into the digital world is the laptop display. Manufacturers use specialized processes to create LCDs or OLED panels. This involves depositing thin films of liquid crystals or organic compounds onto glass substrates. And if the model is touch-enabled, the inclusion of indium tin oxide layers that accurately sense touch. Beyond the electronics, the laptop's body is a marvel of modern materials science and engineering. High-end laptops often use aluminum or magnesium alloys for a premium feel and superior heat dissipation. These metal chassis are typically fashioned using CNC, computer numerical control, machining, a process that carves out the perfect shape from a solid block of metal with laser precision. For other models, injection molding is employed for polypropylene or polycarbonate plastics, offering a balance of durability and cost efficiency. Keeping components cool is crucial. Heat sinks made from copper or graphite are integrated into the design. The chassis itself often doubles as a heat spreader, engineered to distribute thermal energy away from high-performance areas. Designers use thermal simulation software to ensure that every watt of heat is efficiently managed, prolonging the device's lifespan and maintaining peak performance. With all the components manufactured, it's time for integration. The assembly process is a finely tuned dance between automation and human expertise. In state-of-the-art factories, robotic arms and precise pick-and-place machines arrange the tiny electronic components onto the PCB. These machines work with incredible speed and accuracy. Surface mount technology, SMT, then aligns and attaches resistors, capacitors, and semiconductors, which are later secured in reflow ovens that melt solder paste to create durable bonds. As the electronic heart comes together, technicians integrate the mechanical elements. The prefabricated chassis receives the motherboard, battery, cooling system, keyboard, and touchpad. The assembly line guides the partially finished laptop through a series of stations, each focused on precise alignment and secure fastening. Automated conveyor systems, along with skilled human hands, ensure that no detail is overlooked. Quality is paramount. Every laptop undergoes rigorous testing to ensure it meets global standards. Each unit is powered on, and diagnostic software runs through every port, key, and sensor to guarantee flawless operation. Models are pushed to their limits in stress tests, ensuring that they handle peak loads without overheating. Thermal cameras and sensors monitor performance under extended use. Simulated impact tests ensure that the delicate internals remain secure even if the laptop takes an accidental drop. Safety tests verify that the battery management systems function correctly, protecting against overcharging and short circuits. After passing all quality checkpoints, the laptop moves to the final stage, packaging and distribution. Manufacturers now prioritize sustainable packaging. Laptops are packed using recycled and recyclable materials, along with energy-efficient shipping practices. Advanced warehouse management systems and automated sorting ensure that each laptop is efficiently shipped to stores and customers worldwide. Many companies implement take-back programs that allow old units to be recycled. These processes involve disassembling end-of-life devices so that valuable metals, plastics, and electronic components can be recovered and reused, reducing the environmental footprint. From the drawing board to sophisticated semiconductor fabrication, from high-precision machining to automated assembly, the creation of a laptop is an intricate interplay of technology, science, and creative engineering. Every time you power on your laptop, you're engaging with decades of innovation and hundreds of thousands of carefully orchestrated processes. Thank you for joining us on this in-depth exploration of laptop manufacturing. If you enjoyed this behind-the-scenes look at modern technology, be sure to like, subscribe, and share your thoughts in the comments.